So, good evening, everyone, and welcome to this lecture. We were dealing with electrostatics, and in this lecture, we will deal with electric field lines. In the previous one, I think we had dealt with how do you find out, the electric field due to certain types of configuration, and I think we were dealing with a question where we had this. Sphere with a hole, and we had to find out the electric field at different points. Electric field at any point A, which is inside. I told you how to do this. That was 0. Electric field at the center of the sphere, that is definitely 0. You have to find out the electric field.
Excuse me, sir.
Yes, beta.
Sir, we were not there in yesterday's class, sir.
Okay, you were not there in yesterday's class. From where did you miss that class?
From 4:30, sir.
From 4:30, sir. So what was the last thing that you remember from this class? Do you remember this question?
No, sir.
Do you remember this question? Infinite sheet.
Yes, sir, here. After this
Okay.
question, we had some network issue.
Okay, so we had solved this question. We had found out the electric field at all the 4 points A, B, C, and D. Yes or no?
Yes, sir.
Okay, then I had just gone through this question, which was an infinite sheet of width W contains a charge density sigma. So this has a charge density sigma here, and you had to find out the field at 2 points. One of the points being on the axis here, and one was symmetrical to it. So we did not do this question. There was no point of doing it. We had only seen the result for this question, and the electric field at this point P will be given by this formula, where D is the distance of this point from the edge. So it just you that need to draw this diagram and write the result. It will be sigma by 2 pi epsilon naught into natural log of W plus D by D. So that is the only thing that you have to remember. Draw this diagram, a sheet of width W, infinite in one dimension, but it is finite in one dimension. What is the electric field at the point P? And the answer was this one. Do we understand this?
Yes, sir.
Have you noted it down? You just have to note down the formula, nothing else. There's no
Okay.
point of discussing how it is done. It is done by taking infinite long charges and then integrating them. Nothing else. Okay? Shall I move ahead?
We are writing, sir.
Okay. Right. So I'll have to give them 5-10 minutes. So write it. Meanwhile, what the other students are going to do is we had discussed this problem, the last problem of this class, of the last class. So you had to give me the answer for point B and point C. Did you get the answer for point B and point C? You need to work on that problem, point B and point C. We had already discussed what will be the formula for point A and the center of the sphere. So you need to work on that problem till I get these people, these students in line. Have you done this? Yes or no? You done this? Don't have to write the entire question, nothing. You just have to draw the diagram of the sheet, the surface charge density, charge per unit area of this sheet is given as sigma. There is a point P. the width of the sheet is W, and the point P is at the distance. You just have to draw the diagram and write the result. Nothing else you need to do. Okay.
Completed, sir.
Then there was this point which was of more importance. This point looks like this in a two-dimensional figure. Actually, the point is like this. So how is the point? If this is the sheet, it is infinite in this dimension, but it has a width W in this dimension. So this point is somewhere here. That is how it looks in 3 dimensions. But if you try to look it in 2 dimension, you will just see a line and a point. Do we see this? But in 3 dimension, it is like this. Do we understand? Symmetrical. But in 2 dimension, it will look like this. Do we understand this?
Yes, sir.
That is what it is looking like. This sheet is infinite in this dimension, which you cannot see, and it is finite in this dimension. The width is W. And I gave you the general formula. The general formula for this sheet, which is infinite in this dimension, but finite in this dimension, is this. Sigma by pi epsilon naught into phi, where phi is this angle. Which angle? This is the sheet. This is the point here. Phi is this angle, half of this angle. Half of the total angle, this angle is phi. I hope you understand this. Yes or no?
Yes, sir.
This angle is phi. See, the angle between these two lines is phi. This is phi. So you just have to remember this general formula. Now, as soon as the sheet becomes infinite in both dimensions, so it is infinite in this dimension and also infinite in this dimension, that becomes your infinite sheet. The value of angle phi, this angle phi actually becomes 90 degree for infinite. And as soon as you put the formula for infinite sheet, you put phi as 90 or pi by 2. Remember, it should be in radians. You get the formula for infinite sheet. Do you understand this? That is why this is important, because instead of giving you an infinite sheet, they can give you a finite sheet. You just have to remember that. This is the formula for a finite sheet. Sigma by pi epsilon naught multiplied by the half angle phi. Do we understand this?
Yes, sir.
That was the next thing. Nothing extravagant, simple, just because I wanted to give you the concept of a finite sheet. That was the reason that formula was given to you. Noted this down?
Yes, sir. Completed.
Then there was this very simple question, which everyone I think could do this. So I had two spherical shells having radius R1 and R2, charges Q1 and Q2. And I had made 1, 2, 3, 4, 5, 6 points where you had to find out the electric field. Point O was the center, P was inside the first shell, Q was on the surface of the first shell, R was between first and the second, S was on the surface of the second, and T was outside the surface of the second shell. And you had to find out the electric field at the point O, P, Q, R, S, T. And I think you understand how you find it out. Yes or no? At point O, electric field is due to inner shell and outer shell, but this point O is inside both the shells. Therefore, both the electric fields are zero. Do we understand this? Because electric field inside a shell is zero. So electric field at point O is zero. Similarly, electric field at point P. P is also inside both of the shells, and therefore electric field at point P is also zero. We understand this?
Yes, sir.
Point Q is on the surface of one shell. Electric field due to that sphere is Q1 by 4 pi epsilon naught R1 square. But for the other shell, it is still inside the shell. Electric field is zero. For the point R is in between the two shells. Electric field is only due to the inner shell. Electric field due to the outer shell is still 0. Point S is on the surface of the outer shell. So electric field will be created by the inner shell as well as the outer shell. We just put the formula. Point T is outside both of them. So both of them are going to create fields, and those fields are going to be fields created by a point charge. Everyone knows this. Yes or no?
Yes, sir.
So that was this question. It was as simple as it gets. Noted this down?
Noting, sir.
I'll give you 2 minutes to note it down. Note it down, aram se. Meanwhile, the other students, I hope they are working on that question which I gave. Or is everyone chilling out? This is the time to chill, man. Let's bro, chill out.
Completed, sir.
Okay. Everyone completed?
Yes, sir.
Completed, sir.
Yes, beta? Then that was the next question. We were given a spherical shell and we were given a point charge. You had to find out the electric field, no, electric force exerted by the point charge on the shell. The concept was very simple. Action reaction forces. Whatever force this shell is going to create on that charge, same is the force the charge will create on the shell. The distance r was given very large compared to the radius of the shell. It was because that this shell can be then treated as a point object, nothing else. So the answer is simply you find out the electric field of the shell and multiply it by the charge q. Do you understand this?
Yes, sir.
That was this question. I'll give you a minute. Note it down. Yes, other kids, are we solving it? Noted it down?
Completed, sir.
Okay. Then we had a similar problem, but instead of a shell and a point charge, we had two shells and we had to find out the force of interaction between the two shells. Again, the concept is very similar. Distance between the shell was given as very large compared to the radius of the shell. So what you do, you can treat them as point charge. Electric field created by a shell is just like the field created by a point charge. Outside the shell, it is just like the field created by a point charge. So you find out the electric field due to one shell on the other shell and multiply it by the charge of the other shell. Do we understand this? So that was this question. Note it down, fatafat. What this, bacha?
Completed, sir.
Then that took us to the final question of the class, and the question was like this. And I will just take everything out from this question. And now we come to this question. Tung 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 tung. So now this is the question. Now you have a uniformly charged non-conducting sphere of radius capital R. It has a small hole of radius R, which is coinciding with the center of the sphere. We have to find out electric field at point O, A, B, and C. I told these fellows how to get the electric field at point O and A. I also told them how to get the electric field at point B and C. Who will tell me what is the answer? How do we do this? Yes? Huh? Say, your time to become hero. How are we supposed to find out the electric field at point O, A, B, or C, or whatever? Yes? Huh? Do you remember this, or have we forgotten this? It has gone above our head saying bye bye. Bye bye, sir. I'm going. Don't worry about me. Now you must understand that these type of questions are very popular, and at a point in time, this question of what of what of this things with holes were quite popular, and they were like consecutive 2 or 3 years where these questions had come. And if I can find this, let me see if I can get those questions for you. And again, I'm talking about JEE Advanced. I'm not talking about JEE Mains. This question had become quite popular in JEE Advanced, and they used to give them every year, literally. So meanwhile, you can see. Yes. So you have to find out the electric field due to this arrangement. You have to find out the electric field due to this arrangement, and those questions were quite popular, as I was saying. This whole wale question. See,
Sir, I find sir.
I can't hear you, bacha. Can't hear you, bacha.
Rho R by epsilon naught, sir, at point B.
See, rho R by which R?
Epsilon naught.
Huh? What R? Which R?
Big R, sir.
Big R. Anything, sir? See, this was a question that came. I told you, na, it's a question taken from Erodo. The year is not given. I think it's somewhere in the year 2019 or 18, somewhere there. Somewhere there. This one. Where is that question? The whole thing. The whole thing is. Where is that question gone? Maybe it came very recently. It's not there in this sheet of mine. See this one. This is JEE Advanced. There was a point in time where these question of these holes were coming consistently. This one. And this one. Consistently. This is a cylinder with a hole. This is cylinder with a hole. This is the question probably I remember. Cylinder with the hole. Anyways, there's a point in time where this was quite popular. You never know when they can come back in fashion. You never know when they can come back in fashion. Yes, my dear bacha. I think that is it. That was the question probably that was in my mind. Yeah, so I mean, uh, yeah, leave apart whatever. We were here on this question. And how are we supposed to solve this? Yes, bacha, at point A and point B. Now they asked me the hint to solve this, and I gave them this hint that if you have that solid conducting solid non-conducting sphere, the electric field inside this sphere, and it is better to remember it in the vector form, and you will understand why it is better to remember in the vector form, because I have got the JEE wala question also with me just below this. It is always better to remember them in the vector form. It is rho r by 3 epsilon naught, and if you remember, I told you that this is the way I remember it. Yes or no? Huh?
Yes, sir.
Rho r by 3 epsilon naught. So if this is the point P where you are supposed to find out this electric field, it will go radially outward from this point. If the point is somewhere else, again it will go radially outward, and this r vector is the radius vector drawn from the center of the sphere towards this point. Do we understand this?
Yes, sir.
Since we understand this, then we can move ahead and solve this problem. Now, how do you solve this problem? I told you that beforehand, that whenever such a problem comes, I always solve it by the concept of negative mass. Here it is negative charge. The same question can be asked in gravitation there, where they ask you the gravitational electric field. Gravitational electric field? Gravitational field. So when, don't worry, I'll do gravitation as well. Since as soon as your thermodynamics is over in that Sunday wala class, which I think will be over in 2 more classes, I will start with gravitation there. And this gravitation you will see is same as the ditto copy of this. Okay, so how are you going to solve this problem? I'll solve it by the concept of negative mass. Here it is not negative mass, here it is negative charge. So what I'll assume is, I will assume that there is no hole, and this thing is entirely made up of charge with the charge density as rho. Now, if I have to find out the electric field at point A, what do? I can simply write this electric field at point A same as rho x vector divided by 3 epsilon naught. Do we understand this, everyone? This is the electric field created by the entire sphere without the hole at the point A, and this x vector is the position vector of point A with respect to O. Do we understand this?
Yes, sir.
Well done, sir. Then how do I create this illusion of hole? Now remember, I just have to create the illusion of hole. Hole means there is no charge here. If it was a question of gravitational field, it was no mass. Here I have to create the illusion of no charge. So how do I create the illusion of no charge? I superimpose this with a sphere of radius small r having charge density of minus rho. Do we understand this? So this has gone above what it's saying bye-bye. This is the electric field created by this gentleman. The entire sphere without the hole. What will be the electric field created by this gentleman? It is a sphere of negative charge, but the point is still inside the sphere. What is the electric field created by this gentleman?
Minus rho x vector by 3 epsilon naught, sir.
Minus rho x vector by 3 epsilon naught. Because the point is still inside it. That means the net electric field at point A, or for that matter at point O. Point O is always 0 because it is at the center. The net electric field at point A will be the summation of these two electric fields.
0, sir.
I can call this as 1, I can call this as 2. The net electric field becomes 0. Do we understand this, everyone?
Yes,
So that was the first 2 parts of this question that we were discussing. And I had given these gentlemen the next 2 parts, and they have not been able to solve them. How are we going to solve them? Let me go back to the question so that I can get that diagram again. Where is this question? Question, come, question, come, question, come, question, come, question, come. Okay, here it is. So now I have to deal with, I have to go down here. Now I have to deal with the points B and C. Now I come back to this new diagram, fresh diagram with the points B and C. How do I deal with this point B and C? Again, I will have to apply the same concept. I've given you enough time to solve it. Again, I will apply the same concept. There is one field which is created by this entire sphere. This entire sphere at the point B. What is the field created at this entire sphere at the point B? Now, if I write it vectorly, it will be equal to, No one knows the answer. For this sphere, this point B is still inside the sphere. Yes, bacha?
X vector by 3 epsilon naught, sir.
So that is the electric field. E1 rho x vector by 3 epsilon naught. Nothing changes here. What will change here is this gentleman, because now for this gentleman, which is the negative sphere, this point has actually gone outside the sphere. So now I will have to apply the formula for outside the sphere. That's it. What is the formula for outside the sphere? Now it is always good to remember the formula in vector form. Because if the question comes in a JEE, and JEE, I mean JEE Advanced, it will be based on that vector form rather than your whatever form. What is the formula of electric field due to this sphere vectorly? Anyone? Sir, we don't know, sir. Forget about it. The answer looks like this. Let us go back. Let me try to write it in the vector form in the original one. Where is the original? 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 Here comes the original one. Here. Is it coming on the screen now? Here is the original one. This was conducting shell or conducting sphere. The first formula, I don't need vector because it is 0. The second formula, I don't need vector because it is 0. The third formula, how will I write in the vector form? This was the electric field on the surface of the sphere. How do I write in the vector form? I write it like this. Electric field at the point Q can be written as K Q by R square multiplied by R unit vector. A unit vector may not look good, so you can write it as K Q by R cube multiplied by R vector. Do we understand this, or this has gone above and saying bye bye? Bye bye, sir. Over.
That's it, sir.
Good. Then you can write the formula for point R. Here the distance R, you can call it as small r vector. Yes, what is the electric field at the point R? Vectorly. You have 1 minute to show me your talents, else I will show mine.
AQ small r cube into r vector, sir.
Either you can write it like this by small r square into r unit vector. I don't like this form. I like this form better. KQ by RQ into R vector. Well done. Everyone understand this? Yes or no?
Yes, sir.
Then come this one. Solid conducting sphere, which is the question that we are dealing with right now. Non-conducting sphere. We don't need the formula for this one because this is 0. We need the formula for this one. It can be written in this form. I don't like this form, but you can also write it in this form, or you can write it in this form. Now, both of these are scalar formula. I can convert the scalar formula into the vector formula. So how will the green scalar formula look like in vector? How does the green scalar formula look like in vector? Yes, you don't need rocket science to understand this. Rocket science is only applicable in rocket science. Yes. The green formula looks like this. Why I'm writing E always? How does the green formula look like? KQR vector divided by R cube. Do we understand this?
Yes, sir.
This is how the green formula look like, but I don't like it in this form. I like it in the other form, the blue one. In the blue one, it looks like rho R vector by 3 epsilon naught. So far, so good. Let us move on to this yellow formula. This yellow formula is the scalar formula for point on the surface of the shell or the sphere, which is sphere now, not a shell. How does this yellow formula look like in the vector form? No prizes for guessing this because it is same as the formula for shell there. So you can write it like this. Let me not write 1 by 4 pi epsilon naught. Let me write it simply as k q by r cube into r unit vector, r vector. Do you understand this?
Yes, sir.
How does this formula look like in vector then? Electric field at point P, KQ by small r cube into r vector. So now since we understand this, and I think we have noted down this, let us come back to the present. This time machine is going very quickly. And we are in the present here. We are in the present here. Electric field at point 2. Electric field at point B. B is the point in contention here. Can you tell me the formula? Yes.
Rho x vector by 3 epsilon naught.
That is for inside the sphere. Yeah, this point is outside the sphere for this blue gentleman. Oops, wrong color. This gentleman, blue gentleman. Point B is outside. For this pink gentleman, the entire pink gentleman, it is inside. Therefore, the formula remains like that. Okay. No one? Huh? It will be K Q by x cube into x unit vector. But it is in terms of Q with a minus sign because this is negatively charged. So I will just convert this into your form of rho. How will I convert this? I will write this as 1 by 4 pi epsilon naught as K, and I will write this as 4 by 3 pi r cube into rho. This goes away, and I have a very beautiful formula. Very beautiful. It looks beautiful. And what is that beautiful formula that I'm going to get? Huh? Sir, we don't understand it, sir. It's gone above our head, sir. Whatever. What is the beautiful formula? Minus rho r cube by 3 epsilon naught x cube multiplied by x vector. Do we understand this?
Yes,
It has
sir.
gone above our head saying bye bye. Bye bye. I'm going. Okay. So the net electric field at this point becomes vectorly rho x vector by 3 epsilon naught jumps out, and I have 1 minus r cube by x cube. That is the answer, my dear friends. This is for any point B inside the outer shell but outside the hole. Yes or no?
Yes, sir.
Yes, sir. Then the point C remains, sir. For you, sir, to do it, sir. Give me the answer, sir. And stay happy, sir. Point C. And remember, if you are lucky enough, you may get the same question in your examination hall. Yes, I wait for your answers for this green point C. The green point C. The green point C. And it should not take rocket science to give me the answer for C. Huh?
Rho by 3 epsilon naught into capital R vector minus small r vector.
Huh? No. Point is outside, outside, outside. Please remember this. It is outside. Outside, outside. Outside, outside. Outside, outside. Outside, outside. Outside, outside. Outside, outside. Not inside. It is outside. Yes, anyone? I'm running out of patience. No one? Chalo, then I'll have to give the answer. Due to this one, the electric field, remember it is outside. For this, the electric field E1 would be equal to rho by 3 epsilon naught. Radius of this is r cube divided by x cube into x vector. The electric field due to this is again outside. I have written something wrong here. Sorry for that mistake. This should not be capital R cube. This should be small r cube because the radius of the small sphere is small r cube. So sorry for that mistake. This should be small r cube. Okay, now we come to the smaller sphere. Smaller sphere, the answer still remains same. It is outside, so E2 becomes minus rho small r cube by 3 times epsilon naught x cube multiplied by x vector. What you got to do is add these two fields and you will get the net electric field. You will get this answer, rho x vector divided by 3 epsilon naught x cube, everything coming out, r cubed, capital R cubed minus small r cubed. Do we understand this, or this is gone up our saying bye bye, sir? बहुत हो गया. Too much.
Understood?
Everyone?
Yes, sir.
पक्का?
sir.
कच्चा पक्का पक्का कच्चा पक्का पक्का कच्चा कच्चा. Which one? कच्चा पक्का पक्का कच्चा 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 पक्का पक्का. 4 combinations. हाँ? पक्का पक्का कच्चा 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 पक्का पक्का कच्चा. हाँ?
Paka, sir.
This pakka pakka will now become kacha kacha in this question. Now the same question is repeated, but now my dear friends, the point, the cavity is not concentric. The cavity is not concentric. Now, as you can see, this is the same question that came in this JEE, and that is not an original question in itself. This is a question taken from Irodov. This is not an original question. This is a question taken from Irodov. So that is the same question. The question that we have in Irodov is you have to find electric field at any general point inside that hole. And that is what we are trying to do here in this. Now, how do I do this question? So what we are going to do is we are going to break this question into small parts. First of all, you must have some information. You can say that the radius of this is capital R. You can say that the radius of this is small r. But since this hole is not concentric, you must also know the position of this hole with respect to the center of the sphere. So that is given by this vector. Let us call this as r vector. So what things you know is capital R, the radius of the hole if you need it, the radius of the sphere if you need it, small r, the radius of the hole if you need it. R vector is the position of the center of the sphere, center of the hole with respect to the center of the sphere. That is what you will need it. And then you can find the electric field at any of these points. So at which point you have to find out the electric field? You have to find out the electric field at the center O, first point. You have to find out the electric field at point A, the second point. Now remember, this point A ka position is given. You can call it as x vector. You have to find the electric field at point B, which is like this, which is not inside the hole, but is outside the hole, but inside the sphere. And you have to find the electric field at point C, which is outside both of these. In all cases, you will know the position of the point from the center of the sphere, because center of the sphere is the origin of your coordinates. How will you do it? You can start with the first and easiest one. You can also find the electric field at this point P, which is the center of the hole. Center of the hole. So center of the hole, center of the sphere, at any point inside the hole, at any point outside the hole but inside the sphere, at any point which is outside everything. Best of luck. And you don't have to do anything extravagant. Simple things put together from here, and here. Put them together and you get your answer. Remember, this question has come in NIIT. That means it has to be simple. Otherwise, they will not give. Chalo. Let's see who gets me this one. You will have 2 minutes. And don't worry, it's a simple question. Yes, anyone got any answer? Or shall I help you out?
Sir,
At O point is 0, sir.
At point O, it is 0, sir. No, sir.
Huh?
It is not 0, sir.
Rho by 3 epsilon naught into R vector, capital R vector minus small r vector.
Capital R vector. Huh? Okay, let me start with the simplest one. And which is the simplest one? There are 2 points which are very simple. Point O and point P. So let me start with point O. Where is? No, let me start with point P. The simplest is point P. And I can only do simple ones. We have to find the electric field at point P. How will I do it? I only know one tarika. So what I will do is I will imagine that this is the complete sphere. Oh, coloring it will not be a good idea. Hashing it will be a good idea. This will be complete electric field, dung, 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 dung. And then I'll do pung, 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 pung. What is the electric field due to this at the point P? Yes. E1, I'll call it. E1 vectorly will be equal to rho r vector. This is the position vector of the center of the sphere, center of the hole, divided by 3 epsilon naught. Do we understand this?
Yes, sir.
Then I come to this dung, 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 dung. This is the hole, and this is made up of negative charge. But this point is at the center of this hole, right? So this dung, 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 dung will be equal to how much? 0. Yes or no? So I get my first answer. Electric field at point P, which is the center of this sphere, no, center of this hole is rho r vector by 3 epsilon naught. Do we understand this, or this has gone above it saying bye bye? Bye bye, sir. Okay. Done.
Understood, sir.
Understood, sir. Anyone got this answer? Anyone got this answer? No one. Chalo. No one got this answer? Chalo, let me move on to the second point. And I will take the easier one first. So now the easier one is point A. Now this point A is any general point inside this hole. This point A is any general point inside this hole. This point A is any general point inside this hole. Now I know two radius vectors. One is the R vector, which is the position of the center of the hole. And the other one is the position of this. Yes or no? X vector. Do we understand this? Huh?
Sir.
So let us write the first electric field. The first electric field is the electric field created by this entire sphere. I am not going to hatch it again. What is the value of this electric field E1? Tell me. Huh?
Rho R vector by 3 epsilon naught, sir.
What is the electric field created by this entire sphere without the hole at point A? It will be rho x vector by 3 epsilon naught. Yes or no?
Yes, sir.
Let us now find the electric field due to the second sphere, which is this blue sphere, which is made up of negative charge. So it is minus. So now what do I do is, since I don't know the position vector, I will draw a vector like this. And let me call this as L vector. Do you understand? Do you see this L vector?
Yes, sir.
So how much is E2 now? It will be minus rho L vector by 3 epsilon naught. Everyone understanding this, or this is going above our head saying bye bye?
Understood, sir.
Now, how do I get the total electric field? The net electric field will be rho by 3 epsilon naught comes out. What remains is x vector minus L vector. Now, just look at that diagram that I have drawn. And I will just draw it once again. This is your R vector. This is your L vector. And this is your X vector. What is X minus L vector?
R vector, sir.
Well done. It is triangle law of vector addition. So your E vector becomes rho R vector by 3 epsilon naught. And this is an astounding result. Why it is an astounding result? Because this tells us that the electric field at any point A does not depend on where the point is. If the point is inside the hole, it does not depend on where the point is. It only depends on where your hole ka center is. It only depends on the value of this R vector, my dear friend. It only depends on the position of the center of the hole. It does not depend on where the point is inside the hole. Do we understand this, or above or at home? Gone.
Understood, sir.
That is the most important thing that you have to understand in this, because if you could have understood this, then you could have done this. Whatever time you would have taken to read the question, that would have been the time to mark it and get +4 in this tough JEE. Consider the uniform spherical charge of distribution R1 centered at the origin. In this distribution, a spherical cavity of radius R2 centered at P with distance OP is equal to A is equal to R1 minus R2 is made. If the electric field inside the cavity at the position R is ER, then the correct statement is dung 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 dung. Which one is the correct option? Option D. Electric field will be uniform at all the points inside the shell, inside the hole. And the value and the direction depends on the position of the center of the hole from the sphere. Do we understand this? That is how questions are framed. See, it's not an numerical question on this. We are solving a numerical question on this. The question was purely theoretical. Do we understand this?
Yes, sir.
Okay. But our question has not still finished. Our question has still not finished. We have found out the electric field at point P. It was rho r by 3 epsilon naught. We have found out the electric field at point A, general point. It is also rho r by 3 epsilon naught. That means it does not depend on the position of point. It only depends on where the center of the hole is. But still 2, 3 points are left. Point O, point B, point C. What is the electric field at point O, my dear friends? You have 2 minutes to show me your talents, else I will show you mine. Electric field at point O is what I am looking for now. And I hope that someone somewhere will be listening to my voice and will tell me, sir, this is the answer. And I say, wow, wow, shabash. Yes. Yes, 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 yes. Huh? I heard something.
Rho r
like
by 3 epsilon naught, sir.
Rho r by 3 epsilon naught, sir. Sir. How did you get the answer, sir? Tell me, how did you get the answer? Rho r by 3. In the beginning, you said that the answer is 0. Now your answer has suddenly changed. And now it has become what? It has become rho r by 3 epsilon naught. How? Tell me, fatafat.
E is uniform, sir.
There has to be
Some logic, somewhere.
yes, there has to be some logic behind it. We're not playing Kaun Banega Crorepati. Sir, okay, I feel like this is
E
good.
is uniform, sir.
This option looks good. So, huh?
E is uniform, sir.
Is uniform, sir. No, I still not get it, beta. It is uniform inside the hole, beta. It is uniform inside the hole. But we are not talking about the hole now. We are now talking about the center of the original sphere. That is the point that we are concerned about right now. I hope you understand this. Remember, since this question has come once, I mean, a variation of this question can definitely come. It may come in your JEE Main, it may come in your JEE Advanced. So that's why I have dedicated the entire class on this one question. I mean, I have never done that in my life, but I just feel that this question might just come. They might just give you this one. Probably for JEE Main, they will just ask you that question which has already come. But for JEE Advanced, they can ask you other things as well. Yes, so there has to be an answer. Shall I do it? Okay. I have to now find the electric field at point O. O is the point in focus right now. So I do it fatafat now. So electric field due to the first sphere, which is the entire sphere, is 0. Yes or no? Because it is the center of the sphere, it cannot create any field. Now the second sphere electric field will be minus rho into what?
N vector.
It is outside this, right? So remember, it is outside. Rho into r cube by 3 epsilon naught Okay, I have given you the radius and the radius vector as same, so that would create a problem here. I can understand. So let me call this. You have to call it by some other name, otherwise both will get cancelled. So the radius of this sphere, I had given it as r, and let me now call this vector as x vector, so that answer changes. Otherwise, r and r will get cancelled. Okay, by 3 times x cube. But I have to find the position of point O with respect to point P. So it will be minus x vector now. Do we understand?
Yes, sir.
I've taken the vector like this. I should take it like this. So the answer would be this one. Rho r cube by 3 epsilon naught x cube multiplied by x vector, where r is the radius of that hole, not the sphere. Do we understand this? It has gone above what it's saying, sir. Ho gaya. Done. Yes or no?
Done, sir.
Point B remains. How will you get it for point B? How will you get it for point B? How will you get it for point B? Point B. Point B is here. So I am going to call this vector as x vector. This vector as L vector. And this vector as R vector. Can you now tell me the answer in terms of X, R, and L? Yes. Everyone understands the question now? Everyone understand the question now? Everyone is silent. Why so much of silence? Remember, the same question may come in your JEE. So just imagine that this question is coming in your JEE and you have to solve it that way. Because in JEE, you might not get so much of time. And you will have to do it quickly. So if you can do it quickly now, probably you will get the same sort of, even the symbols might be same like this. And remember, you will not be lucky. You don't call yourself lucky. You will call yourself smart hard worker, that you had already done this question before. That was not luck that came in between. That was your work, smart work that has come, that has helped you out. Luck never helps you. Luck only helps you when you are playing akkar bakkar bambe bo 80 90 pure 100. Then luck comes. You have 4 options and you start playing. Okay, since I have nothing to lose, I know that I am not going to clear JEE. So let us play akkar bakkar bambe bo. So then you start akkar bakkar bambe bo 80 90 pure 100. Dam. That is luck. Else, nothing is luck. Everything is your hard work coming from somewhere. Yes. Do I have an answer coming from anywhere? Can I hope for an answer dropping from somewhere so that I can go and catch it? Answer catch. Or I will have to do the needful.
Sir,
The answer may look a bit complicated, but yes, tell me. Someone was saying something. Yes, say.
sir,
Yes,
yes,
say. Chalo, tell me the value of E1. E1 is the electric field created by the bigger sphere without the hole. Can anyone tell me what is the value of E1? Say. Are? Huh?
so r cube by 3 epsilon naught x cubes into x, r vector into x vector.
Rho r cube by 3 epsilon naught x cube multiplied by x vector. This is what you are saying, yes or no?
Yes, sir.
That is absolutely correct. No problem. That is absolutely correct. What about E2? The field created by that hole. The field created by that hole.
Vector 3 epsilon naught.
Rho by 3 epsilon naught into L cube. This one? This one?
Sir,
Don't you think we have written the thing in the reverse order? Don't you think we have written it in the reverse order? I feel so. Because for the first sphere, this point is inside the sphere. So the answer for this one will be rho x by 3 epsilon naught. Do we understand it, bacha? But because for this bigger sphere, this point is inside the sphere. And for this hole, this is outside the sphere. So for the hole, the answer will be rho L vector by 3 epsilon naught into outside wala formula for outside into R cube by L cube. Do we understand this?
Yes, sir.
If you add these two fields, you will get the electric field due to this sphere with the hole at point B. This question can only come in JEE Advanced. It is way beyond the limits of JEE Main. For one, it is inside. For the other one, it is outside. Do we understand this?
Yes,
Everyone?
sir. Yes,
Then
sir.
comes the last one in this category. The last one in this category. And what is the last one in this category? You have to find the electric field at point C, which is the exact question that came in this JEE. So this is the question that we are going to do. Sphere with the hole outside the sphere. And this is the motivation for us. What is the motivation for us? See, this question came in one of the JEEs, 2012, one of the more difficult JEEs. See, you see this question? And this is simpler compared to what we are doing, probably, because we are doing it in the most general form. This is a cylinder with a hole. But once you understand this question, if you know the formula for cylinder, you will be able to find out this cylinder with the whole thing. So this question and the question that we are doing are exactly similar. There is no difference. In fact, our question is difficult because our hole is not concentric, our hole is somewhere else. So our question is a lot difficult than this question. This is a 4-mark question from JEE. 4 marks in JEE mean a lot. It may mean a difference in rank of 4,000 ranks even. So let me tell you what things are known and what answer you have to give. So this is your R vector, the position vector of point P. If you want, you can use it as R vector. This vector, I will call it as the X vector. I am giving you the most general form. And this vector I will call as the L vector. So now you have to give me the answer in terms of these 3 vectors. Exactly 7 minutes are left, 3 minutes for you and the rest for me. So I will be back at 17:26.
Sir,
Yes.
rho by 3 epsilon naught into capital R cube X.
Yes. I'm listening. Yes. Sheet is there in front of you. We lost it somewhere.
Rho by 3 epsilon naught into R cube by X cube X vector minus L vector by L cube.
R cannot be same. See, I've just heard your answer and I thought that you have kept the same R. And that is the problem. One R is the radius of the bigger one R is the radius of the smaller one. They cannot be same. Bacha, do we understand this? Cannot be same.
Rho by 3 epsilon naught into capital R cube by X cube X vector minus small r vector by L cube.
No,
vector.
smaller, no, smaller, no. Okay. Take a long, deep breath and then you concentrate. E1, electric field to 1, rho, capital R cube by 3 times epsilon naught x cube into x vector. Do we understand this? Capital R is the radius of the bigger sphere. Then again, you take a long, deep breath and then you write the value of E2. And we have written it so many times that we must know it. Rho small r cube divided by 3 times epsilon naught x cube. Oh, see, I have also made a mistake. Not x cube. The position vector is given by L vector. So I have to divide it by L cube into L vector. This will be the answer. Oh, this is not the answer. I made a mistake. It should be negative over here. Then we must add these two fields and that would be the answer. So your final answer will look like this. E net vectorly, I can only take rho by 3 epsilon naught outside. And the rest of the things will be inside r cube by x cube times x vector minus small r cube by L cube times L vector.
Sir, we got the same.
Congratulations. That is the most difficult question that can come, as you can see. Even JEE asked a simple one. So I will give this question as a homework for you. The only thing you have to find out is what is the electric field of this solid cylinder. If you find it out, you will get the answer straight away. How will you find it out? I leave that to you. So see if you can do this. I will not be doing it now. Once I understand, once we do this solid cylinder, then we will come. Remember, Gauss law is still not started. We'll start Gauss law in the next class. And only after doing questions from Gauss law we will have enough weapons in our hand to get this. Okay. In Gauss law, we will be doing some question based on Gauss law, and we will be finding out electric field due to all these gentlemen once again. Don't worry. I have left some derivation because they were not required. I will do some derivation because they are required. Okay, I only do things which are required. Things which are not required, I will not do it. We don't have that much of time. So take care. Have a nice day and God bless all of you. Do practice questions because the only way you become good is by practicing. Now I've given you enough questions on holes and this that even in your dream you can write the equation for the electric field due to a sphere here and sphere there, and that too vectorly. So congratulations. Take care. Have a nice day. God bless all of you. Bye.